Okay, for the last chapter, chapter 5, strictly speaking, Woodridge mentioned somewhere at the beginning of chapter 5 that he wouldn't recommend this chapter to be prescribed. So, but I think for this chapter, I think there are two topics that I think it's worth covering. Okay, but I'm not going to go through the slides. I think this study guide and then this summary highlights video will be enough. Okay, first of all, the consistency property. Do you still remember from your Eco 242 regarding the consistent property? It says, maybe I make use of these figures. Should I enlarge it? Okay. It says as sample size gets bigger and bigger, then the sample regression function parameters would converge towards the true PRF parameter. So this is an example. If my sample size is small 100, then this is the graphical sketch of the sample regression function parameters. You see the huge variance. But as I increase my sample size to 5,000, do you see this B2 head would converge closer to the true B2? You see the smaller variance. And then again, if I increase the sample size further to 3 million, you see the smaller variance. And then finally, the extreme case, if the sample size is exactly the same as my population size, and it means I interview everyone in the population, then the sample regression function parameter would be exactly the same as the true population regression parameter. Okay, so this is what you learn from 242. But then now we interpret this consistency property one step further, actually. The argument is that the story is not as straightforward as that, because if we suffer some sampling omitted variable bias, which you learn from chapters 2 and 3, then consistency property may not hold. In fact, the direction of the bias of the parameter is actually the same as the direction of the inconsistency. It sounds a bit confusing, but once I make use of this figure, you can understand. Okay, so can I enlarge it further? Okay, this is the story. Okay, let's say I commit maybe underfitting or overfitting. Remember from, is it chapter 2 or chapter 3, you know about the direction of the bias, is it upward bias or downward bias. So look at this example. So this is the true PRF slope parameter, true B1. But because of certain problems with my regression, I suffer downward bias in my regression parameter due to, let's say, underfitting. Then I end up estimating the slope parameter as BC instead of B1. So it means downward bias in the slope parameter. And then even if I increase the sample size, you see, even as small n sample size increases, my sample regression parameters would only converge, but converge to BC instead of B1. Okay, so then in other words, I would say the direction of the bias of the parameter, downward bias, and the direction of the inconsistency of the parameter in the same direction, both downward bias. So I repeat, the regression commits, let's say, underfitting, and then downward bias in the slope parameter. So the true B1, the true slope parameter is B1, but due to the downward bias in the slope parameter as a result of underfitting, I end up estimating the slope parameter as only BC, which is far away from B1. Then even if I increase the sample size, then my sample regression parameter would only converge around BC instead of B1. So I also suffer the downward inconsistency of the parameter. And similarly, so this is the important thing, same direction of the two types of problems. Similarly, let's say now in my regression, again, I commit underfitting, overfitting, or using the wrong functional form. Then there is something wrong with my slope parameter. And let's say this time I commit upward, there is upward bias in the slope parameter. So this is the true slope parameter, B1. But unfortunately, due to certain specification errors in my regression, there is upward bias in the slope parameter. So my B1 head would, even if I increase my sample size, they would all converge to BC, which is much greater than the true B1. Then I suffer upward bias in the slope parameter and also upward inconsistency in the parameter. Okay. So I hope you are happy with this. And then the last topic is the LM test, Lagrange multiplier test. Okay, I think you learned it from Eco 311 actually. Another test on the restrictions on parameter, which you already learned another F test from chapter 4, I think, on F test on the restrictions on the parameter. So LM test is another test. So I want you to go through these steps. They might sound confusing. This is why my graphical sketch would make things simpler to understand. So can I stop for 1 minute for you to go through these a little bit confusing bullets? Okay, so let's rather look at my graphical sketch. Okay, so I want to start off with this unrestricted regression model. Okay, so I've got 5 explanatory variables, x1, x2, x3, x4, x5. And then this is my restricted model. I only include x1, x2, and x3. So in other words, I actually impose 2 restrictions, that b4 equals 0 and b5 equals 0, so that x4 and x5 would not feature in my restricted model. So 2 restrictions. So Q stands for the number of restrictions imposed in the restricted model. And then I extract residuals from this restricted model. Okay. I have to do it actually because you don't have a computer with you when you write a bootcamp test. Then I run the regression. I have to provide you information on this regression. The residuals derived from the restricted model is a function of the explanatory variables from the unrestricted model. So in other words, this time x4 and x5 feature. Then I derive R squared. I have to give it to you actually. R squared from this unrestricted regression. And then I calculate the LM statistic, which is n times R squared. N is the sample size. R squared is the R squared from this regression. Eh? Okay, from step C. Then I look for the chi-square test statistic. Degrees of freedom is actually the number of restrictions Q imposed in the restricted regression. And then if LM stat, which is n times R squared, is greater than chi-square statistics, then we conclude that there is something wrong with the restricted regression. Okay. In other words, it is wrong to impose restriction. So let's do 2 questions. The first one, this is the restricted regression. I only include study hours, but I exclude party hours. So there's 1 restriction. And then the unrestricted regression is marks explained by study hours and party hours. Then for the restricted regression, after running it, I extract the residuals and then I run this auxiliary regression. Residual from the restricted regression is a function of all the explanatory variables from the unrestricted regression. And this is the R squared. Then I can do the LM test. Step 1, you should be fine. Null hypothesis. Restricted regression is fine. Alternative hypothesis, something wrong with the restricted regression. Step 2, n20 times R squared from this regression, then 1.212. Chi-square statistics, number of restriction is 1, and then alpha is 5%. Then we use the chi-square table, 1%. Okay, 1 restriction. Okay, 3.84. Okay, 5%, sorry. This is alpha 5%. 1 restriction, 3.84. Okay, and then since n times R squared is smaller than chi-square statistics, the null hypothesis is not rejected. Therefore, actually your restricted regression is fine. So it means this regression is fine. So maybe the argument is that if I include party hours, it is too strong correlated with study hours, because usually those who study longer hours, they will spend less hours partying. So maybe the argument is that if I run this as an unrestricted multivariate regression, there is imperfect collinearity present. Okay, so maybe the restricted regression, which takes out the party hours variable, would really be better. Okay, then last question. Okay, the person runs the regression, restricted regression. Okay, sample size is 25. So MP3, this is the restricted regression. MP3 quantity demand of MP3 is a function of the price of the CD. Okay, and then the unrestricted regression, quantity demand of MP3 is the price of CD, but you have two more explanatory variables, price of MP3 and income. So in other words, there are two restrictions imposed in the restricted regression by assuming the slope parameter of this and the slope parameter of this both equal to 0. So two restrictions on the slope parameters of this regression. And then I extract the residuals from the restricted regression, and then I run the auxiliary regression. And then this is the R square. Then I conduct the LM test. So first step, you should be fine. Okay. Second step, N25 times R square. 9.9875 chi-square statistics, two restrictions, alpha 1%. 1%, two restrictions, so 9.21. Okay. So since n times r squared is greater than chi-square statistics, then the null hypothesis is rejected. Okay, then it means this time we reject the null hypothesis, meaning the alternative hypothesis would take place. It means the restricted regression is not specified correctly. Okay, so in other words, it means the unrestricted regression is better, and I think it is the case. Because the price of MP3 should feature, to explain quantity demand of MP3, remember the law of demand, and I think income should feature to explain quantity demand of MP3, because I think MP3 nowadays is no more good. The higher the income, the higher the quantity demand of MP3, assuming you pay legally to download the MP3. So I think compared with the restricted regression, the unrestricted regression is indeed better. Okay. So I think that's it for chapter 5. And in fact, I have covered all the chapters. Okay. Chapters 19, which relates to your Eco 701. Chapter 1, which is the basics. Okay. Just to refresh your memory on what you learned in Eco 2 for 2 and 311. Chapter 2, mainly on the bivariate regression. Chapter 3 on multivariate regression. Chapter 4 mainly focusing on the statistical test, confidence interval hypothesis testing, t-test, f-test, and Chapter 5 the two minor topics about the consistency or inconsistency property, more in-depth explanation. Now you know that the direction of the bias of the parameter is the same as the direction of inconsistency of the parameter. And then finally the LM test, which is the other test to test for whether it is a correct decision to impose restrictions on the parameter. So I think that's it. That's all from my side. So good luck to your bootcamp test.